how we define a conformity. One, you see the angular relationships, this order, textbook. You know what you're looking at, and you can demonstrate that you're looking at a Miocene versus an Oligocene rock. You know you're in nonconformity. Here it's a little bit different. Here, it's more from a process-driven approach. And the reason why I showed you those beds at Mayaro is because what Phil is cleaning there, I hope you can see the similarities. That's pretty much what we just left in the Mayaro formation. All thousands of feet of it. These low-angle cross-stratified sands. And you can see them expressed all here, low-angle cross-strata. Which one person suggested, and I agree with him, was probably deposited where the rain was falling. Way out near the shelf edge, probably. But not as far as the shelf edge, but certainly on the shelf. Lying above that, there's no debates whatsoever. It's a relatively thick lignite-rich mud and lignite bed. It's a combination. It's not all lignite. You've got some mud in there. But it's lignite-rich mud and lignite bed. So what we've done, we've juxtaposed two environments that are not together in space. They're not spatially juxtaposed. It suggests that there's a gap occurring just at this point. It suggests there's a huge gap in time, or at least in environments, occurring at this time. So one interpretation of this is that this surface here represents a significant unconformity. The evidence that agrees with this, and I brought this map. It's not really a map. So one of the things that agrees with that, and no VJ scientists, what we do, we build evidence, but we can't see the data. So only on this map, just below that red and yellow circle, that's Phil's Mayaro town. You see the yellow on the edge? You see that yellow? That yellow is the palmis that's exposed on this side. And then all that green behind it is the Mayaro, which occurs behind there. So the mapped contact for the Mayaro and the palmis is somewhere here. I don't know where it is exactly, but it's somewhere here. So we have a map contact. We have missing strata. I think this is a classical unconformity. There's another model. Anybody can think of another model which would not put a time gap there? And? Could be. Like slumping. Slumping, right, but no evidence for strata. I should add one piece of evidence. If you get a chance to look at those sands above it, I don't know how many of us will be brave to climb. Very, very different to this. Those are tidal deposits. Those are strongly probably tidal deposits. Very, very different to this environment that we're looking at. So we have a change in deposition environment.
So the alternative is this is not the Mayaro. It's an environment that we didn't see in the Mayaro.
That we didn't see in the Mayaro?
In the Mayaro. It has to be something like a beach or barrier bar sequence. So you can then put your pools right behind it. Right. And then behind that, how do you get it tight? But we'll talk that. But what you have to do is to take a jump and say, okay, to get the sequence, he's actually right. You either have a jump in sequence, or you have to have a completely different sequence, not what we saw in this. You can't be on the shelf and then suddenly jumping into cool. That just doesn't make sense, okay? So this would have to be you have to find evidence that this was a sand that was distinctly different from what we saw today. Okay? And we have
beach and barrier systems can look like this.
In Nariva, the Cocal, for example, would have a beach barrier bar system with a long strip. Think of that. And then right behind that, you have your mangrove swamp. Okay, so and you know, we can sit here all day and discuss. I think both hypotheses are worth moving forward with, because it's good to have two hypotheses, because you test yourself in questions. Right?
So
anyway, no, go ahead. So
I was going to add that the things I'd love to see sort of confirm or deny are rootlets. Rootlets would suggest you have exposure and whatnot. Difficult to see rootlets, I was looking for it from here. The thing I'd also like to see within this section, which will support the Mayaro, is the ophiomorphas. Any of us have walked these outcrops. Ophiomorphas are all over these things. If I see one indication of an ophiomorpha in here, I have a better tie back to what we saw in the first time. Alright, so keep your eyes open if anyone sees anything. I haven't seen anything. You want me to keep going?
His job isn't done yet.
Indeed, by popular consent, I should spend the rest of my life cleaning the outcrop.
Second that motion.
Oh yeah. Look at that. It's not massive at all.
So we've got that going forward, and for those of you who would have seen anything on the stratigraphic work we kind of put forward, it's going to revisit things like this, try to document some of these sites. So we have it for generating moving forward. Right now we don't have this accurate documentation. In a modern sense. We only did a good job 70 years ago.
Still
We're going to put this in a modern sense.
organic.
Yeah.
It is better.
Easy.
Looks like a piece of wood.
Yeah, it is better. Was that true? That's true.
In the interest of time, I'm going to take anybody who wants to go.
I think we should take them at least to see the tropic pool and see those what we think are trees in the roof of the Everybody, you all have all seen this log here.
Yeah.
This is a large log, right? You see it there? And if you look underneath, what we're trying to decide is, there are other ways of getting coals into position without necessarily having them deposited in situ. So now we're trying to look for evidence that said this coal was actually deposited here, not retransported. Okay, you can read all the sands that we saw, those little clay the coal laminations. Certainly this morning we saw them. Disseminated coal. You can move coal. It's not a big deal. You can move leaves. You see leaves all over the beach in Mayaro. I mean, it's not a big deal. So what we're now looking for is a statement that we can say, well, no, this is actually in place. And this is a hint. This tree logs have actually, if you look at the beds below from a distance, you'll see that they're actually sagging underneath. Okay? That's either compaction or the fact that the tree fell right there. Perhaps. Bent the beds underneath through squeezing them, right? So those are the kind of hints we're looking for. And when we go up this outcrop, we're going to try to convince you that we can actually show you a root system that shows that the tree was growing there. So we have the log, and then we'll try and show you the trunk sticking up, okay? Which kind of suggests that didn't get transported, okay? So if you want to scramble up, well, first of all, get your eye into the fact that this is a clay unit. It is not all lignitic. It is quite rich in lignite, right? For those of you who like thinking about dip and strike, this is a wonderful outcrop to understand what apparent dip and apparent strike is like. It's not often that you get a nice surface like this that goes from looking like it has no dip here to all the dip is over there. Remember one more thing before we go, because we're talking about dips. We were at an outcrop not long ago where the dip was to the Mayaro. Which way was it dipping? This way up the coast, right? Remember that? So that was north. North here is that way. Okay, so this outcrop is dipping that way. Remember we told you about the lizard's anticline? So this is dipping into the Pilot syncline, which is between where we were and here. But it's doing more than that. It's wrapping around the nose of that anticline. So you're getting not just south, but you're getting a little bit of south and east.
That's the anticline there.
Yeah? So you're on the flank of the anticline. And you're starting to feel it with the direction of the dip, right? It's actually quite a cute little structural story that you can picture right here. There are places where you can see the palmies definitely with a different dip than the Mayaro. I could have taken you there on the way here, but in the fullness of time that will come on another trip. But it is important to realize that these guys, when they did do these maps, they did them by trenching, and they took the dips and they knew what the hell they were doing, right? They may not have been absolutely correct, but relatively, I think they didn't do those things without having a feel for why they were doing them. All right. So that's, if you can pop up, I think it's a good lesson to be learned.